In this stoichiometry class, the topics we are going to cover under this is that first, we are going to cover many things under here. We are going to cover many subtopics under this. And one thing about that is that stoichiometry is one of the major places as a major areas that examiners actually ask what questions, deep questions when it comes to what both your JAMB, both your WAEC, and both your what NECO exams. Most exams always have what stoichiometry, and stoichiometry actually goes across almost all the whole calculation you have in your chemistry. Almost all the whole calculations. We may not finish it now. The stoichiometry we are going to do now is going to be stoichiometry part 1. That is what we are going to do. We are going to do later stoichiometry part what 2 later. But now what we are going to cover here now is stoichiometry part 1. The major basis of what stoichiometry, we are going to cover it what now. So maybe later, maybe in our next chemistry class, we are going to now do stoichiometry part 2. Because stoichiometry is very, very what big. Do you understand now? So we are going to do stoichiometry part 1. So after this stoichiometry, our next topic will be chemical combination. Chemical what? Combination. Those are the major things we are going to talk about. Our next topic will be chemical combination. So we are going to talk about majorly about even chemical bonding. We are going to talk about some of the laws that guides what chemical what combination. So after this stoichiometry, we are going to do that. Now let's kick off. So now in chemistry, we have two major analyses in chemistry or experiments that we'll carry out. And those two major experiments are always what? Quantitative analysis and what? Qualitative what? Analysis. Quantitative analysis and what? Qualitative what? Analysis. Now when we talk about quantitative analysis, it's an analysis we do to determine what? Quantity, to determine volumes. Examples of analysis that you can find under there is something like a titration. If you want to do any titration now, the major thing you want to determine is what? You are going to determine what? Volume of the acid, right? You determine volume of base, right? You also determine concentration of the what? Unknown. Major titration is actually done to do what? To determine the unknown what? Concentration of either the base or what? The acid. Is to determine the concentration of the what? Unknown. Do you understand now? That's the major difference. And that titration is found under where? Quantitative what? Analysis. Now, another analysis is qualitative analysis. Qualitative analysis. In the qualitative analysis, you are actually talking about, you're actually trying to check majorly the content. What makes up this? That's the qualitative analysis. And in the calculation of qualitative analysis, that's where we are going to get what? Stoichiometry. So your stoichiometry is also covering even the practical aspects of chemistry. All the calculation that has to do with practical aspects of chemistry. Even some of the theoretical aspects in chemistry. Because some of this stoichiometry will also cover your what? Some of your gas laws. Calculation of stoichiometry will cover what? Some of this thing in what? In gas what? Laws. Do you understand now? We are going to still cover it under what? Stoichiometry. Gas laws like Gay-Lussac's. Do you understand now? We're going to cover it under what? Stoichiometry. But now, I want us to follow it step by step. Do you understand now? I want us to follow it step by step so that we can actually understand it. First, I'm going to divide this stoichiometry into different categories. So we can be able to do what? To know it very, very what? Well. So that at the end of the day, we can be able to what? Know this part 1 very, very well. Then in our next lesson, we will now do part 2. We will now do it what? Another way again. Do you understand now? So, but what you know in your part 1 will help you in what you're going to learn in what? In part 2. In part 2, majorly, I'm going to bring the stoichiometry with formulas. Now, in this part 1, now I'm going to treat the stoichiometry without formulas. You get that now? Those are the major things. Now, first, I'm going to start with mole to mole stoichiometry. Now, I'm going to talk about mole to mass stoichiometry. Then after that, I'll talk about mass to mass. I'll talk about mole to volume. I'll talk about what? Mass to volume. Volume what? To volume. Now, before our stoichiometry class, there are some certain things you have to learn before you learn your stoichiometry very, very well. What are those things you have to learn? Those things you have to learn first is that you have to know how to write your chemical reaction and balance it. Right? Know how to what? Know how to what? Write and what? Balance what? Chemical what? Reaction. That's the first thing. Know how to write and balance. Now, that's the first thing and the most basic things first. The first thing and the most basic what? Things first. Another thing again I want you to know in stoichiometry is that in stoichiometry, you always compare two species. You always compare two species. And the species you're always going to compare is one species will be what? We have value. We have what? Value. Why the other will not have value? Now, the third thing again you are going to know before this stoichiometry is that how to convert. How to do what? Convert. It's not converting of centimeter to meter. This time around is from how to convert from mole to mass. How to convert from mass to mole. How to convert from what? Mole to volume. How to convert from what? Mass to what? Volume. And etc. How to do what? Convert. If you know these three things, you are good to go in stoichiometry. And we are going to learn these three things first before we now do what? We will now actually enter mole to mole stoichiometry, mole to mass, and mass to mass. Anytime you are confused, you can raise up your hand, ask your question, then we can carry what? On. I want you at the end of this class, you should be able that because we're going to solve, I have like close to like 50 questions on stoichiometry here that has to do with stoichiometry part 1. Then when we now do stoichiometry part 2, we have close to like 150 questions to go. So we have 50 questions here, we have 150 questions. We may attend 10 or 15 in this class. You will not attend 10 or 15, which I know you will not do in your free time. But you try to do what? To do it. We'll find a way you are going to do it. True or false? We'll find a way you are going to do it. True or false? How many of you did my assignment in my last class? Raise up your hand first. Let's down your hand. First of all, when I said, I think most people that came in my last class actually did my assignment. True or false? Now, because we are actually trying to repeat some of the things we actually did in our last class, we'll use some of those things as our class work now. That assignment I gave to you people. We are going to use this as what? Some of our class work. Then we'll now check your corrections. Do you understand now? So now, let's start with things to know. First thing, know how to write and balance chemical reaction. How do you write and balance chemical reaction? Those people that came in Alaska, the first thing I focus on is how to write chemical reaction. So this is going to be another advantage to them that are going to do what? They are going to learn it what? Twice. Do you understand now? But now, those people that have not actually learned it before, just try and keep your what? Just try and learn it very, very what? Well now. Just keep, in case if you are confused, you can ask your what? Question. Now, first thing I did was that I said that for you to write chemical, for you to do what? Write your chemical reaction, first of all, you have to start with writing compound. Writing what? Compound. You have to start with writing compound first. From compound, you can now start with doing what again? You will now start writing some chemical what? Reaction. Do you understand now? And for you to write your compound, you must know what? Your valencies. And I told you that you don't need to cram all your first 20 words valency. And I taught you a cheat code on how to what? So do it. Is it not true? Now I'm going to now teach you the cheat code now for those that was not in the class. I said that in the first 20 elements, in fact in the whole elements, we have two states. A two states an element can be. Two states an element can be. The two states are one, duplex states, and two, octet what? States. All elements are trying to be in these states. All elements are trying to do either in duplex states or in what? Octet states. It's only elements that are already in duplex states and octet states are the rare gases. If we not call them rare gases, what do we call them again? Noble gases. It's only noble gases or rare gases that is already what? Having these states, either duplex states and what? Octet states. Now I want to give you an example of something. Now, the rare gases or noble gases are like the big men. The big men that already have everything they what? They want. They have children, they have cars, they have jeep, everything they want. They don't hustle again. They just come outside and just travel. They go to maybe USA, they go to America, they don't hustle again. They're just telling their children, why are you hustling? They're even telling their children, you don't need to hustle, just relax. Now, every day, anytime they are carrying their motor or passing on the road, you yourself you're watching, say, I want to be like this man. They already at the level where people want to be what? Like them. That is how the noble gases are. The noble gases are already in this state. So melters and non-melters are trying to be like them. Melters have too much they want to give out. Non-melters does not have. What do? They want to do what? Collect. They want to take. That's why they are taking from melters. So they can be either in this state or in this state. So at the end of the day, every element is trying to be in this, either in duplex states or either in what? In octet states. Do you understand now? So every element are trying to be what? In either in duplex states or what? In octet states. Now, how did this thing now come in place? Now, in octet states, in duplex states, every element that is going to be in duplex states is going to have what we call what? K shell. You know, you have many types of shell, right? We have K shell, we have what? L shell, we have M shell, we have N shell, we have O shell, we have P shell. Now, but those ones now, the first shell we know is K shell. And in the K shell, every element that has K shell, do you understand now? All of them, for them to be stable, they have to be in duplex states. Do you understand now? So now, K shell is the first shell. Look at it here. It's the first shell. Now look at it. So this particular one have electron at the outermost shell. Is not true. It has electron at the outermost shell. Now, for the first element, which first element do we have? Hydrogen. So it has only one electron. Do you understand now? And it's found in the first shell. The second one is what? Helium. This one is filled up, right? So since if it's already two electrons, it has actually what? Filled up. And this first shell is what? K shell. This first shell is what? K shell. And it's already in what? In duplex states. Do you get that now? It's already in what? In duplex states. But in this first one now, it's K shell, but it's not in duplex states. How many is it looking for to be in duplex states? One. Do you understand now? So it is one. It is remaining one for it to be in duplex states. Now, since you already know these stories and everything, now in octet state is from what? L shell. So for L shell to be complete, it must be in duplex state. As in octet state. That means how many are supposed to be outside here? 8, right? You can see there's going to be 8 outside here. Once it's 8 outside here, we'll now see that L shell is what? Complete. Do you understand now? And it is in what? In octet state. Do you get that now? So those are the major ones now. But now, let's carry on now. So any elements between for hydrogen and helium, for you to find their valencies, we are going to use 2. You know 2 is what? Duplex state, is not true. We are going to use 2 to find it. So you use 2 to minus how many electrons you can find their atomos shell. Then you can now find their what? Valencies. So let's do it now. So we are going to start with hydrogen. The hydrogen now, we are going to have how many? 2 minus 1 electron. It has 1 electron at the atomos shell, right? So what is going to be the valency now? 1. Do you understand now? So coming to the next one, which is what? Helium. Helium now have how many electrons at the atomos shell? 2. 2 minus 2 give you what? 0. The valency is what? 0. Do you get that now? So for you to get the valency of those ones in a duplex state, you use 2 to do what? Minus it. Do you understand now? Now coming to those ones after helium, what do you have next? Lithium. Now this lithium now has passed this the first stage, which is this one, this K shell, is now heading to what? L shell. For you to head to that L shell, what is going to happen now? Look at the secret now. If you see 1 electron at the atomos shell, or you see 2 electrons at the atomos shell, or you see 3 electrons at the atomos shell, or you see 4, any of this number you see, either 1, 2, 3, or what? 4, that becomes their valency. That becomes their valency. Look at what I mean. Now, if I have, this is medium, right? This is K shell, 1, 2, and this is what? 3. Do you understand now? 1, 2, and this is what? 3. So now, how many electrons do I see in the atomos shell? 1. This one becomes their what? Valency. So what is now this thing here? 1. Did you see it now? Now, in the next one, after lithium, what do you have next? Beryllium. Thank you. Be. How many did you see at the atomos shell? 2. What is their valency? 2. Did you see it now? Now, the next one is what? After beryllium, boron. So, now, how many electrons at the atomos shell? So, what is now the valency? 3. Now, after boron, what do you have next? Carbon. So, we have carbon here. So, how many electrons at the atomos shell? 4, because they are what? Valency. Do you understand now? So, now, what now happens? When this thing crosses, you know, I just listed 1, 2, 3, 4, right? What now happens if this thing now crosses 4? Because you know, after this carbon now, the next element we are heading to will pass 4 at the atomos shell. Is it not true? So how many will it have? It's going to have 5. Is it not true? So what now happens? Is 5 going to be their valency? No. What we are going to do now is that we are going to now use 8 to subtract anything we see at the atomos shell. So the atomos shell is 5. As well as it is more than 4 now, we use now 8 to what? To subtract it. If we subtract it, we can now get their what? Valency. So for nitrogen that has 5 at the atomos shell now, so we'll now say 8 minus 5 will give us what? 3. So 3 becomes their what? Valency. Do you understand now? Now, after nitrogen, we have what? Oxygen. So what will now be the valency of oxygen, class? 8 minus 6, which is 2. You already know valency of oxygen before now, which is what? 2. Now, after oxygen, what do you have next? Fluorine, which is what? 8 minus 7, which is what? 1. Then after fluorine is what? Neon. So 8 minus 8, which is what? 0. You know that neon is a noble gas. So a noble gas is all their what? All their valencies are what? 0. We saw it in helium. Helium was 2 minus 2, which gave us what? 0. Is it not true? Helium is 0. So all the valencies of noble gases are what? 0. Do you understand now? So the same way all the whole this, even neon, 8 minus 8 is going to give us what? 0. You understand now? So after that, we will now head over to sodium. In sodium own, all the whole L shell has what? Has filled up. We entered the next shell, which is what? M shell. So you now have how many electrons at the atom shell? 1. So that means the sodium valency is what? 1. So we have actually learned the trick of valencies now. How can we now use it to form compounds? Since we already know it, how can we now use it to form compounds? Almost all the compounds you know, most things you use in forming compound is using their what? Valencies. Because valency means combining power. For an element to form a compound, that means it have actually done what? Combine. And for it to combine, it must have a what? A power. Even though it's 1, that 1 is also a what? A power. Do you get that now? So that is why majorly you are not seeing what is it called? Noble gases in combining. Why? Because their power of combining is what? 0. Their power of combining is what? 0. So that is why you are not seeing them combining. How many times have you seen neon reacting? How many times have you seen helium reacting? How many times have you seen argon reacting? Because they have a 0 combining power. So now, because of what we have learned, we are going to use this and now do what? We are not going to use it and form some compound. From forming compound, we will form some reaction. From forming reaction, we will now go to the next 2. Then we will now start our what? Our main stoichiometry. Remember, we are still in the introduction side. Do you understand now? But anywhere you are actually confused, try and do what? Ask question. Do you understand now? Because the teaching is actually step by what? Step. So if you miss this step, you may not actually understand the next step. Now let's go. Now, is a neat duster, okay? Now let's carry on with this space now. Now let's form compounds. I can just bring any element and we use it to form compound. Any element at all, we just use it. So let's combine some elements. Let's bring hydrogen, let's bring oxygen, let's bring sodium, let's bring fluorine, let's bring potassium, let's bring sulfur, let's bring aluminium, let's bring oxygen. What again? Just bring some combination. Magnesium and okay, someone say carbon. So let's say magnesium and what? Carbon. Let's use all these things and form from what we have actually do what? Learn. Now, what is the valency of hydrogen? We'll put 1 on top here. That's the combining power. What is the valency of oxygen? We'll write these 2 here. Now, what are we going to do? We cross multiply their powers. Do you understand now? We cross multiply their what? Powers. When 2 cross multiply this, it's going to turn what? H2. Then 1 times O, we write what? O, we don't write 1 in chemistry. If you write 1 in chemistry, the God of chemistry will fire your head. So you don't write it. So you just leave it. Once you write it here, just look around. Something may hit on your head. Boom. So just have it in mind. Just write it. Just write. Don't write 1 here. If you write 1 here, you look like who? How do you look like? Let's continue. Now, let's continue now. What's the valency of sodium? 1. So the valency of sodium is 1. Fluorine is what? 1. We cross multiply. Then we'll now write what? Sodium what? Sodium what? Fluoride. This one is forming water. Do you understand now? This one is forming your normal what? Water. This one is what? Sodium what? Fluoride. Now have it in mind now. Have you seen I didn't put 1s here, right? Because you know that this is just 1, right? We cannot write that 1 here. Then the next one is what? Potassium. What is the valency of potassium? Is C what? 1 from what we did. Now sulfur 2. We cross multiply. 2 times K, K2. 1 times S, S. Now this one is going to be what? Potassium sulfide. Now the next one, aluminium. What is the distance of aluminium? What's the valency of aluminium? 3. What's the valency of oxygen? 2. Then we'll cross what? Multiply. 2 times Al will give me what? Al2. 3 times O will give me what? O3. Do you understand now? Have you seen? From this now, you can now know how to write compound. We'll start with the compound of the first 20 elements. Then later I will now show you how to write the other compound. After this, I'm going to show you how to write this with ozone ions. So I'm going to show you some ozone ions and their what? Their oxidation numbers. So now, magnesium is what? 2. Carbon is what? 4. We cross multiply. So when we cross multiply, this magnesium will have what? 4. This carbon will have what? 2. But is this our final answer? No. 2 and 4 can divide. When we have something like this, if they can divide, they can still divide it. Do you understand now? So since 2 and 4 can divide, they can divide further and make it simpler. Make it a simple what? Ratio. So this 2 will divide 7. We call it 1. But you know, we not write 1 now. Should I write 1? Now, 2 divided 4, we have what? 2. So at the end, we have Mg what? 2C. So this is magnesium what? Carbide. So that is it. So please copy and be what? Happy. Then we can continue. Now please, from this, did anybody have any question? Did anybody have question? No. Other elements have valences. We are going to treat about other elements valences when we do periodic table. Do you understand now? But I'm going to show you some other elements, major elements we use, their valences and others. So, do you understand now? Even when we are actually writing reactions, I'm going to show you how to even know other elements what valences. Those people that was in my last class, I taught you how to do it now. Even if I didn't tell you the valency, from the chemical reaction, you can actually know their what valency. Can we continue? So let me clean this side. Any other question? Now, let me write ozone ions. Majorly, when writing a reaction, we don't ignore ozone ions. Ozone ions has to do with all those radicals that has what? Oxygen. All those radicals. What are radicals? All those radicals are the ones that have not actually become what? They are not stable. The major reason why elements combine, you see sodium and chlorine every time. You now see sodium chloride. What is the major reason why they combine? They combine so that sodium combines so that it can release that extra electron it has. Chlorine combines so that it can collect that what? Extra what? Electron that who is giving? Sodium. Now at the end of the day, chlorine is happy being stable, being in octet state. Sodium is also happy being in octet state. The two are now in octet state. They are now combined. You understand now? But there are some elements, even as they combine, they are not still stable. Do you understand now? Those elements that are not still stable after combining, we will call them what? Radicals. And now, I want to ask you a question now. Let's assume now, radicals now, they are very, very what? Aggressive when reacting. Now, I want to bring an illustration to you. If, for example, now that this particular young man is looking for 10 million naira. Do you understand now? And someone now give this young man 8 million naira. How much is remaining? 2 million naira. Now, if I'm also looking for 10 million naira and this man is looking for 2 million naira, who do you think will be what? Will be looking for how to complete his money very fast? Me first, I'll be discouraged. Where will I even start looking for 10 million naira? This man already have what? 8 million naira. So he will rush around and say, even if it's 100,000, no, I can raise my money very, very what? Fast. But me, I will discourage and ask myself, where will I come and start looking for what? 10 million naira. If I ask you that I'm looking for 10 million naira, you have only 1 million naira. You look at me and say, how will you even help this young man? Because if you give me 1 million naira, how many is remaining? 9 million. So this young man will be what? looking for a way to do what? To find very what? He'll be looking for a way to what? To find that 2 million naira complete with 10 million naira very, very what? Fast. That's how radicals is. So radicals have actually collected. By the end of the day, they are not actually what? Stable. But now the radicals that now have oxygen, we call them what? Also what? Anions. Also what? Anions. And that's the major ones that react well. There's one major ones you see in your what? In what's it called? When doing reaction, you see them very well. Mostly this one, SO4. You see this one majorly very well. You see something like CO3. You see something like NO3. Mostly OH. Mostly these ones, these four now, these are the major ones. First of all, we're going to do radicals. When we do radicals, we'll talk about all of them. But these are the ones I want to talk about. So I'm going to talk about their charges, their oxidation numbers. Anytime you see them, the same way you cross multiply this, that's how you're still going to cross multiply that particular. But as you're treating, you're going to treat them what? As one. You're going to treat them as what? As one. If you look at them, you see that there's so for here, there's oxygen. They have actually combined, but they're not actually what? Stable. This carbon and the oxygen have actually combined, but the carbon is not yet what? Satisfied. The nitrogen, you have actually also combined, but not actually what? Satisfied. The same thing is happening to what? Oxygen and hydrogen. Oxygen has what? Can collect what? Oxygen needs 2 electrons, but hydrogen can only donate what? 1. We saw it here. So it needs 2 hydrogen to satisfy who? 1 oxygen. So you can see it here. It needs 2 what? Hydrogen to satisfy who? Oxygen. So if we have 1 hydrogen, what do you think will happen? 2 of them will be looking. How oxygen will be looking around? I beg, give me just remaining 1. It's just remaining 1. Just give me. It's just remaining what? 1. That's how you'll be looking at. So this one now, the oxidation number of this is 2. The oxidation number of this is what? Is 2. The oxidation number of this is 1. The oxidation number of this is 1. So if I have something like sodium, we have something like SO4. Remember that this one is 1, right? So this one is going to be what? 2. You cross multiply. It's now going to be what? Na2SO4. Have you seen how we got this thing now? These 2 cross multiply here. So if you have something like hydrogen, I have SO4. Do you get that now? So this is having 2 and this one is having 1. What will happen? You cross multiply. This 2 comes here, it's going to be what? H2. 1 times here is going to be what? SO4. So then at the end of the day, what do you have? What do you have? What is the name of this compound? Tetrodosulfate 6. Either you still call it tetrodosulfate 6 acid because of the presence of hydrogen, or you call it what? Hydrogen tetrodosulfate what? 6. Then this one is what? Sodium tetraoxosulfate 6. We are going to talk about IUPAC nomenclature of inorganic what? Compounds. It is one of the topics, I think, is under which this, I think it's after this chemical combination we are going to talk about it. Now, after that, you can see that's the same way you combine all these things. That's the same way you combine all these things. You get that now. Now, if you now see, so this one is 2, this one is 1, this one is also what? 1. Do you understand now? Is there anyone you want me to combine with any element here? The same way I do this, that's the same way you can do all these ones. You treat them as 1. One thing again, you know I used only the one that has 1 valence, right? What if this is combining with something like aluminium? Aluminium has a valency of 3, right? And then combining with SO4, let's assume you see something like 2 here. So what are we going to do? Cross multiply. So have 2 times this is going to have what? Al2. Now this 3 now, will I write this thing as SO4 3? You will now see SO4 getting 43, SO43. Do you understand? No, you will not write it like that. Because you are treating all these things here as 1. Do you understand now? So this 3 will multiply everything that is what? Here. And maths taught us that. If we have a number multiplying a what? A particular what? Subject, what do? We'll put it in what? In parentheses. It's not true. So we're going to put this thing in what? In parentheses. So this 3 now, this 3 that is outside means that this 3 is multiplying everything that is what? Here. Do you understand now? This 3 is multiplying everything that is what? Here. Is everybody confused here? Thank you. Can we continue? Now, it is now how to now write chemical reaction. Chemical what? Reaction. There's some chemical reaction I gave you the last time. I want to write it on the board so we can use this one. Instead of those hard ones we used. So we can write it, combine it, and at the same time balance it. Is everybody writing here? Should I clean this side? Please, someone that attended that last class should give me. I want to write one of those compounds in this book. Emma, from the last class, I want to see. Let me see. Let's just like. Thank you. So now we have. Is this in Al? Okay, yeah, that's Al. Aluminum oxide. Okay, I'm not. I want to use this one as it is like first. Now, when you want to, you're using this to write, right? Okay. When you want to react, when you look at a chemical reaction always have something like this. You have AB plus CD is going to give you, this means results to, maybe let me just say
cross multiply. 1 times Al is Al. Remember, we don't write 1. 3 times this is going to be what? Cl3. So it's going to be what? Aluminium chloride. So we have Al what? Cl3. Have you seen it now? This is it. So once I give you something like this, you can be able to put it in this place. Put it very well. Now, for you to write chemical reaction is not enough. Another thing you have to have in mind is how to also balance it. For you to write it is not enough. What you also know is how to do what? Balance it. Writing it is not enough. Balancing it is another stuff. Do you understand? So let's now learn how to balance it. Now, if you want to now balance this, first, there are some principles you have to have in mind. You always balance oxygen last. Then another thing again, you can balance anything. You always balance if you have hydrogen. After balancing hydrogen, before you now go and balance what? Oxygen. So you balance hydrogen second to what? Last. Hydrogen second to the last. These are the major things you have to put in mind. For you to do what? To balance oxygen last, balance hydrogen second to what? Last. Then you can now balance any other, any other element that comes. Now the idea there is that most of the times, after balancing all those elements, coming to hydrogen and oxygen, they are already what? Balanced. But most of the times, when you want to balance, if you want to balance oxygen first, you may get confused on the way. Sometimes, if you want to balance hydrogen, you may also get what? Confused. Do you understand that? So you always balance what? Hydrogen or what? Oxygen what? Last. Do you get understand? So now, those are the major things you have to have what? In mind. So you always balance what? Oxygen last, then hydrogen second to what? Last. Those are the major things again you have to have in mind. So now, let's balance this and maintaining those things. Here, we don't have hydrogen, right?
Yes.
But we have oxygen here, right? So let's maintain it. Aluminium, how many aluminium do we have here? 2. In the reactant side. For here, how many aluminium do we have here? 1. So now let's make this aluminium 2 here the same way it is here. We don't put number in the middle here. You don't put number down here. You can only put number here in front of those elements or compound. That's where you can only put number. You don't put any number down here. You don't put any number in the middle of any compound. You just put it what? In front. So now, at this particular point in time, aluminium is now how many here? 2. Aluminium is now how many here? 2. Aluminium is now balanced. Now coming to the next one, sodium. How many sodium is here? 1. How many sodium is here? 2. So let's balance sodium. We are going to now put 2 here. Sodium is down 2 here. Sodium is down 2 here. Sodium is down balanced. Now what is the next element here? Chlorine. Remember that as this 2 is in front of here, it's also affecting chlorine. Yes. So here now we have 2 sodium. We also have 2 what? Chlorine. You understand now? We have 2 sodium. We have 2 what? Chlorine. So we have 2 chlorine here. Now coming to this side, do we have 2 chlorine here? Yes. How do we have 6? We have how many chlorine here? 3. That's 2 times 3, which is what? 6. Do you get that now? So at this particular time now we have 6 chlorine. Now, if we have 6 chlorine now, we want to correct it here so that here will be 6. You know we are going to clean this 2 here, right? And now put 6 so that this chlorine and this chlorine will be tally, right? So we'll now put 6 chlorine here. But now, if we now have 6 chlorine here, you know that we have actually distorted sodium. Sodium is now 6 instead of being 2. What are we going to do? We will now add a number to make this thing to also be 6. We cannot claim these 2 here and put 6 here. No. You leave these 2 here and ask yourself, what will you multiply by 2 that will give you the same value of 6? Which is what? 3. So you put your 3 here. So that 3 times 2 will give you 6. You get that now? 3 times 2 will give you what? 6. Gotten? Now, at the end of the day, we have actually balanced almost everything. The only thing that is remaining for us is now oxygen. Now, oxygen here is 3. How many oxygen do we have here? 3. Automatically, the oxygen is now what? Balanced. But if you go to go and balance oxygen first, you may have issue. Do you get that now? But if you balance oxygen, if you always put that principle, balance your oxygen last, balance hydrogen second to last. You also do what? You know that you know how to balance very, very well. Because of time, we may not continue balancing and balancing and balancing again. Do you understand now? So now these are the principles. I want you to ask questions here. If you have any question, I want you to now enter the main stoichiometry. Two things I always have. Sometimes I will mention like four compounds or 3 compounds. The compounds you are paying attention to is one compound. Let me give you an example. I mean, just like you're not asking how many moles. I want to just give you a small example before I continue. How many moles of oxygen will be formed when 7 moles of let me just say how many moles of hydrogen. Let me just give that. When 7 moles of oxygen molecule reacts with hydrogen or with excess hydrogen. Let me just react with hydrogen. Let me use steam here. Okay. I just want us to use it. Let me use how many moles of or even water. Say the middle ones we use water. Let me say how many moles of water will form when 7 moles of oxygen molecule react with what? Hydrogen. What are the things you hear here? Water, oxygen, hydrogen. Those are the 3 substances that was listed here. And I told you that the major things you actually mentioned is what? You're actually comparing just 2 species. You are comparing just 2 what? Species. Now, from this now, water was mentioned. And they asked you how many moles of water. Do you get that now? How many moles of what? Water. You should have it in mind. So this one now is what you are actually having in mind. Now, another one I said that you should bring the one, you should compare it with one that already gave you the value. Now, another one you are comparing is will be formed when 7 moles. Do you get that now? When 7 moles of what? Oxygen. The value of this one was given to you. But this one, the value of this one was not even given to you at all. But this one, you are looking for the value. So what you are using to compare is what? 7 moles of what? Oxygen and also what? Water. Nothing concerning and this what? Hydrogen. Do you get that now? So first thing to do is to write your reaction. They ask when oxygen reacts with what? Hydrogen. So you have it in mind. It's H2O2. You don't want to be H2. Hydrogen is a diatomic what? Element. Oxygen is also a what? A diatomic element. So if I say H2 plus O2 will give me what?
H2O2.
H what? 2O. You have it in mind. This is it that you not show. H2 plus O2, I put it out to write your chemical reaction. It's going to form what? H2O, which is what? Water. Then you now do what again? You balance it. How many hydrogen do you have here? 2. How many oxygen do you have here? Sorry, how many hydrogen do you have here? 2. How many hydrogen do you have here? 2. How many oxygen do you have here? 2. How many oxygen do you have here? 1. How many oxygen do you have here? 1. So what are you going to do? You put 2 here to balance it, it's not true. At the end of the day, how many oxygen do you have here? 2. Then here, oxygen is now 2. But you have actually discarded what? Hydrogen. Hydrogen is now how many here? 4. 2 times 2, which is what? 4. So what are you now going to put here? 2. You will now put 2 here so that the hydrogen will have here is what? So now, they ask him now that this is 2 moles of hydrogen now. Reacting with what? 1 mole of hydrogen. So 2 moles of what? Hydrogen need to react with what? 1 mole of what? Oxygen to form 2 moles of water. This is what this reaction means. This reaction means that 2 moles of hydrogen will always react with what? 1 mole of what? Oxygen to form what? 2 moles of what? Water. That is what this reaction means. This reaction means that once you balance it, you can now make what? This statement. 2 moles of hydrogen will always react with what? 1 mole of what? Oxygen. Oxygen to form what? 2 moles of what?
Water.
2 moles of water. This is what it is. Now, in the question says that how many moles will be formed when what? 7 moles of oxygen molecule what?
JAMB.
Do you understand now? So anything that always reacts here will always be what? 1 mole of oxygen. So what you are comparing is oxygen and water. These are the only 2 things you are doing what? You are comparing. Oxygen and what? Water. Nothing again, nothing concerning this what? Hydrogen. So you always circle what you are comparing. So if you have this thing already, how many moles of oxygen do you have here? 1. How many moles of water do you have here? 2. So it's not that 1 mole of water, 1 mole of oxygen will always give you what? 2 moles of water. 2 moles of what? Water. So now, for the question, like you now have 7 moles of oxygen. How many moles of water will you now have? It will not be what? X. True or false? Yes. So it will not be what? X. So you now have a what? X. You cross, multiply. 1 times X, X. 1 times X, X. 7 times 2. 14. So that means you now form 14 moles of water. Do you understand? Anytime you have 7 moles of water, you now have what? 14 moles of. Sorry, every time you have 7 moles of oxygen, you now have what? 14 moles of water. Now we are going to talk about this very well now. But what I want you to understand is that when doing stoichiometry, you always compare to species. One you are looking for the value, and the one that they gave you the what? Value. Do you get that now? When you are looking for the value, the one that I call what? that was the value was actually what given to you. Do you get that now? So those are the major things you have to have in mind. So the third one, what's the third thing I say you must know? What is something I say is I give you three things. First thing, you must know how to write and balance your chemical reaction, which I've actually taught you. The second thing, you must know the value, the ones you are looking for, the ones, the substance you are looking for, the ones that was given, the value was given to you, and the ones that the value was not given to you. So what's the third one? How to what? Convert from mole to mass. Now, how to convert from maybe mass to mass or mole to mass? Now listen. Listen, everybody. How to convert now? Now, how to now convert? There's some certain things you have to have in mind. The certain things you have to have in mind is that we have mole inside here. So you should have this in mind. Mole. We have mole inside here. I want to put mass. I want to put volume there. See, knowing this now will help you very well. Knowing this, like this, I say mole to what? Faraday constant. Mole to what? Mass. Mole to what? Volume. Mole to what? Amount of substance. Let's start with mole to what? Mass. First. Every element, most things you have to have in mind is chemistry is that first of all, they always give you the mass values. But what if it is not given to you in exam? Because JAMB can be crazy. That's why you also have to know the mass of every element, especially the first 20 elements first. Then later, we will now start talking about other elements. So when we start doing electrolysis, you don't know about the copper, you don't know about the silver, the what, the gold and other things. But the major ones you have to know now is the first 20 what elements. Do you get that now? So now, how do you know it now? One pole of every element has its own mass. And you have a way of knowing the mass. Look at how to know the mass, the easiest way of knowing the mass of every element in the first 20 elements. Now, apart from hydrogen, apart from nitrogen and what? Chlorine. Hydrogen, nitrogen and chlorine. The mass of hydrogen is 1. The mass of nitrogen is what? 14. And the mass of chlorine is what? 35.5. I'm going to teach you a cheat you can use to know all the mass of all the first 20 elements. So, the mass of hydrogen is what? 1. The mass of nitrogen is what? 14. The mass of chlorine is what? 35.5 grams. Have it in mind. Know this for 3 things. This is 5.5. When we now do, what is it called? What is that topic again? No. What is this topic? That has to do with, what is that? This isotopy. Okay. You now know why we are not approximating this. This is a round, that's relative atomic mass. You don't approximate it, it's like that. So now, apart from that, element like, you see helium. This number is, helium is number 6, not true. And this number is what? Is it an even number or odd number? Even number. For you to get, apart from these 3 elements, for you to get their mass, if it's even number, just double it. So what will now be the mass number of helium? 4. Now the next number is 3, which is leading. For you to get for leading, what you're going to do is what? You double it and add 1. So you now say that's what 3 plus 3 plus 1. 3 plus 3 is what? 6 plus 1, 7. 7 gram is not going to be their what? 7 gram will be what? The atomic number. The atomic mass. The next one is 4. The 4 is what? Beryllium, right? Now the beryllium now is not going to be what? 4 plus 4 plus 4 plus 4, which is going to be what? 8. And this is 8.9 plus something. And this is up to 9 gram. Sorry. So put this one here. Beryllium. I think this is 9 gram. The beryllium is also what? 9 grams. So put this one here. So 5 is what? Boron. So boron is what? 5 plus 5 plus 1. Because 5 is what? An odd number. So what is now going to be this thing? 11. So elements like sodium, what is now going to be the atomic number? Sodium is number 11, it's not true. So which is what? 11 plus what? 11 plus 1, which is what? 23 grams. Elements like oxygen, what is now their mass number? 16, which is 8 plus 8, which is 16 grams. Do you get that now? Do you get the idea now? Yes. Magnesium is what? 12 plus 12, because it's an even number, which is what? 24. Now, you have a question?
Yes.
Okay.
And sometimes you say that the odd number, like an element is an odd number, you add the two, like
You double it and not add one.
The nitrogen, the element
It's 7. 7 plus 7, which is 14. You can, if you add 1, it's supposed to be 15.
Yes.
But we're not having 14 grams.
right?
Gave us the what? The mass number. They believe that at that stage, you should have actually known the what? Mass number. But if it's not given to you, remember this sheet. If it's given to you, you use what they give to you. But it's always the same what? Value. Do you understand now? So that's one of the things we're actually trying to play at. Now, do we understand what I'm actually saying here? Yes. Can we continue? Now, what does this thing mean? It means that 1 mole of sodium is going to be equal to what? 23 grams. 1 mole of sodium always contains what? 23 grams. So the mass of sodium is what? 23 grams. It's not true. Yes. So if you want to now say that you want to convert 1 mole of sodium to mass, you say it's what? It's equal to what? 23 what? Grams. Do you understand? So 1 mole of aluminium is equal to what? 1 mole of aluminium will equal to what? What's the number of aluminium?
27.
13 plus 13 plus 1, which is going to be 27 grams. Thank you. So it's going 1 mole of aluminium is equal to what? 27 grams. Now, what of hydrogen? 1 mole of hydrogen is equal to how many?
1 gram.
1 gram. That's it. If you know how to convert all these things, you should know. So anytime you want to deal with mole and mass, you convert it from mole. Every element 1 mole. If you are not dealing with 2 moles of sodium will not be how many grams?
Will be 46.
2 moles of this is now going to be what? 2 times this 23. Yes. Because you already know 1 mole is 23. So that means 2 moles will now be what? 2 times 23. 3 moles will now be what? 3 times 23. 4 moles, 4 times 23 for sodium. Do you get that now? So can we carry on?
Yes.
Thank you. Now that's how to convert mole to mass. Coming to volume. The volume that was given to us is at STP. Volume at STP, the value is 22.4 dm3. The value is what? 22.4 what? dm3. the value of volume at SCP is what? 22.4 dmq. That is the value of what? Volume at SCP. Now, the volume at SCP, now let's put this down. If we have that means that 1 mole of sodium will contain how many volume at SCP? 22.4 dmq. So every element will contain what? 22.4 what? dmq. Is it that if it is hydrogen, it will contain how many volume? 22.4 dmq at SCP. Helium, 22.4 dmq at SCP. Lithium, 1 mole will always contain 22.4 dmq. They are standard. That are what? Standard. This is what it means. So anytime I want you to convert to volume, first thing to have it in mind, because it's stoichiometry, you start from what you know. All these things will not be given to you. It's the belief that you should have known it. You start from what you know to what you don't do, what you don't know. Do you understand now? From what you know to what you don't do, what you don't know. So now, that is for volume here. Now the next one is amount of substance. According to the scientists, Avogadro's, he says that each particle, atoms or molecule contains 6.023 times 10^23. So 1 mole of each element will always contain these things, atoms. So you know what this thing is? I think it's 60 billion or 60 million. You know what this thing is now? 6.023 times 10^23, not in naira. These are just, if you put it, I don't know why money is entering your mind. So now, if you bring this thing down now, this is close by 600 billion or something like that. But that's what I forgot to admit. He said that if even this phone now contain how many? 6.023 times 10^23 particles. Even this marker, if you break it down, you get what? 6.023 times 10^23 what? Particles. If you break this 6 down, you get what? 6.023 times 10^23. So if you have 1 mole of each element, each element, it always contain what? 6.023 times 10^23. Now I want to ask you a question. 23 grams of sodium will contain how many volume at SCP? 23 grams of sodium, how many volume will it contain at SCP? 23 grams of sodium, how many volume will it contain at SCP? Someone said 1. 22.4 dmq. Now I just rephrase the question. Now let's see. This is what I did. If 1 mole of sodium contains 23 grams, and 1 mole of sodium we see contain what? 22.4 what? dmq, right? Yes. That means 23 grams of sodium we see contain 22.4 dmq. The question says, if 1 mole of sodium contains 23 grams, 1 mole of sodium still contains 22.4 dmq. That means 23 grams of sodium will contain what? 22.4 dmq. Do you get that? Yes. Someone is still confused. There's the same statement, but it just how would I put it? Now 1 mole of sodium is 23 grams. That's the value. Now 1 mole of sodium is still the same as what? 22.4 dmq. And I ask you, 23 grams of sodium will contain what? It's still going to be what? 22.4 dmq as volume. Do you understand? The same 23 grams of sodium will still contain what? 6.023 times 10^23. I want you to play around with these values. Do you understand? All these values are equal to 1 mole, equal to 1 mole, equal to 1 mole. Do you understand now? So now, 23 grams of sodium will contain 6.023 times 10^23. Do you understand now? Because this 23 grams of sodium is the same as what? 1 mole. Do you understand now? So it's as if me and myself, I'm writing 1 mole here. But I'm writing it in terms of what? 23 what? Gram. Do you understand now? So that is what it means. So 1 mole of sodium will contain 6.023. That's 6.23. That means that 23 grams of sodium will still contain 6.023 times 10 to the power what? 23. You should have it in mind. All these conversions, they are still the same. Let me put it like this. Let me give you an instance so you can understand. If I say Godwin is answering how many names? 3 names. Godwin is answering 3 names. If I call him Godwin now, he will answer. If I call him Michael now, he will still what? Answer. If I call him who again? Chemere, he will still do what? Answer. Only him. Only him is answering 3 names. And all the 3 names, I let him know the one that is the son name. So now in the 3 names here now, you see that Michael, Godwin, Chemere, he can just actually answer the 3 what? Names. Now, in the same way, here I'm actually still telling you that 1 mole of sodium, if I call it 1